Hi guys, this is Mrs. Gessler, and we're going to talk about the history of the atom in pictures. I have some handy paper here because I couldn't find any thermal paper this morning, and I didn't feel like printing any out, but you should have plenty available, so why don't you go ahead and use that. Our essential question that we have today is how did the model of the atom change over time? Now we're going to talk about the pictures of the atom as time goes by, and oh, that's a question, right? Okay, and we're going to draw kind of how it started. Now, a long time ago, these ancient Greek people, they didn't really know what matter was, so they came up with some explanations, and as time went by and they did more experiments, they figured things out. And we're going to start our history with this guy named Dalton. And his first name was John Dalton. He had this idea that there were atoms. So he had that atoms exist. And he just thought they were some sphere, some ball here. So if we like shade this in to make it look more like a ball, it's a solid sphere. You can't break it. You can make other materials out of atoms. So like if you have an element, it's all one atom. And then he said that compounds are combinations of atoms, and that when there's some sort of reaction, the atoms change arrangement, but the atoms themselves can't be broken up. So that's an important part of John Dalton's theory. You can't break up the atom. It is a solid sphere. So here we're going to put the name here and the picture here. Okay, solid thing, can't break it. Okay, now fast forward some time. There was this guy named J.J. Thomson with no P. I always put the P in there accidentally. J.J. Thomson had some more equipment that Dalton didn't have access to, and maybe had Dalton had access to this equipment, he would have been able to figure this out. But he used something called a cathode ray tube, which uses electricity and magnetic fields to do some pretty cool stuff with atoms. And he found out that there's actually different charges inside the atom. And so his picture of the atom, he wasn't able to see inside the atom, so he knew that there were opposite charges. He called them plus and minus. I think he was the one who coined the term electron for the minuses and proton for the pluses, but he could have just as easily picked something else. But he thought that they were just kind of all willy-nilly in here. They sometimes call this the Plum pudding model, which might mean nothing to you, but there's this dish in, I think, England, where they take plums and a whole bunch of other stuff and mix it up. It's kind of like cobbler. But the gist is everything is all mixed up. Okay, plum pudding means that it's all mixed up. Now, fast forward some more years, and this really nice guy named Ernst Rutherford. Ernst Rutherford had even more equipment that J.J. Thomson didn't have access to, and they call his experiment the gold foil experiment, but he figured out that there is a nucleus. So his main addition here is that all that positive is in the middle. That's all he did. He already knew that atoms existed. J.J. Thomson knew about atoms. Rutherford knew about the charges inside the atoms, and his experiment showed that those charges are in the middle. So that center is called the nucleus. Now, that's all he was able to figure out, but then came along this guy named Bohr. And Bohr figured out through his equipment that those electrons are not just willy-nilly all over the place. Okay, so the nucleus has the positives, the electrons are around the outside. Bohr said, yes, the nucleus is there and it does have positives in it, but those electrons, instead of being just wherever they want, are on these rings. Okay, so he added organization to the electrons. The electrons have to be in particular places. So you can see that with each guy, we get a little bit of a better picture of what the inside of the atom looks like. Now, did it end with Bohr? No. There's this other guy named Schrödinger, which you'll talk about later on, I'm sure. who figured out a little bit more about how those electrons have to be in those orbitals, those energy levels, and that it's a little bit more complicated than Bohr originally thought. There was also this other guy who he didn't really change the picture too much, but he came after Bohr. I don't know why I put the star there. He came after Bohr. His name was Chadwick, James Chadwick. And Chadwick said that, you know, in addition to those protons, there are neutrons in the middle. So Chadwick added neutrons to the middle of the atom. Now, you might be wondering, well, we were able to see the inside of the atom here. Why couldn't he find the neutrons there? Well, J.J. Thomson was able to see all this stuff because the positives and the negatives, they interact with different things. They repel and attract and whatnot, but neutrons are just there. So they weren't able to detect those this way because here they were just looking at the charges. They were able to see things because of the charges. Bohr was able to see things because of the electrons. We had to get some more sophisticated equipment to be able to see some mass, a very tiny itty-bitty little mass, without the charge. Okay, detecting just mass that doesn't interact with anything is quite difficult, so it took some time. In fact, this was in like the 1930s, I want to say, kind of fairly recently in comparison to these other guys. So Chadwick added the neutrons to the nucleus. Those are in the nucleus. Nucleus. There we go. All right, so there is a brief history of the atom. We'll explore these a little bit more in depth later on, but for now, that's where we'll stop. Thanks for watching. Ask questions if you have them.